Welcome to the Deep Dive. Today we're really diving into serverless applications, focusing specifically on the Cloudflare platform.
Yeah, we've got a great source here, the book Serverless Apps on Cloudflare by Peacock.
And our mission, really, is to pull out the core ideas, the practical stuff, about building with Cloudflare serverless tools. Think of it as, your fast track to understanding Cloudflare's power.
Exactly. We'll guide you through what the book covers, starting, right from deploying your very first worker,
The base.
all the way to the more advanced things like serverless databases, AI integration, even real-time apps. The goal is for you to really grasp what's possible and how it all fits together.
Okay, let's start with that term, serverless. It sounds
Yeah.
almost too easy. No servers. What's the actual deal?
Well, fundamentally, serverless just means you, the developer, don't have to worry about managing the underlying server infrastructure anymore.
Right, that burden shifts.
Precisely. You focus on your code, deploying it, and the cloud provider, in this case, Cloudflare, handles all the server provisioning, the scaling, the maintenance, all that stuff behind the scenes.
So if I'm looking to build an application, what are the immediate, payoffs I'd notice?
Oh, there are several really compelling ones. First is probably the pay-for-what-you-use model.
The cost aspect.
Yeah, your build based on actual usage number of requests, compute time, not for a server just sitting there running 24/7, even when idle.
Which can save a lot, especially if your traffic goes up and down.
Definitely. Think about a seasonal promotion. With old school servers, you'd pay for peak capacity all year. Serverless costs just scale with the actual demand.
That makes a ton of sense.
Yeah.
No wasted capacity. What else?
Well, built-in scalability is huge. If your app suddenly gets popular, the platform automatically scales up resources to handle the load. No frantic calls at 3 a.m. to add more servers.
Okay, that's a big relief.
And high availability is basically baked in too. The platform is designed to be resilient, often running your code across a global network. Plus, like we said, no server maintenance. Forget patching OCs or worrying about hardware failures.
So it really comes down to simplifying things for the developer, letting them focus purely on the application logic and the user experience.
Exactly. It lowers the barrier to entry and speeds up development and deployment. And that's where Cloudflare really shines. The book stresses their platform is built for engineers.
Right, not just abstracting things away, but giving control.
Yeah, control and flexibility. And their growth trajectory suggests they're becoming a really major player here.
Okay, Cloudflare's a serious contender. How does the book structure this journey for us? How do we get from zero to, understanding this whole platform?
It's structured pretty logically, chapter by chapter. We'll be drawing from sections on the basics. Cloudflare workers, their compute units, then building APIs, managing data with their D1 database.
D1.
Using KV for caching, R2 for object storage, even workers AI for artificial intelligence, and pages for static sites, durable objects for real-time stuff. It covers a lot.
Sounds comprehensive. All right, let's jump into chapter 1 then. Deploying that first Cloudflare worker. What tools do we need to get started?
Cloudflare gives you two main tools. There's the wrangler CLI, the command line interface, gives you lots of control. And then there's C3, which stands for Create Cloudflare CLI.
C3. Sounds like it's for getting started quickly.
Exactly. It makes the initial project setup super easy. These are your main ways to interact with the platform for building and managing your apps.
And the book uses C3 to kick things off. How does that work?
Yep. You just run a simple command in your terminal, npm create Cloudflare at latest.
Okay.
It'll ask you a couple of questions. Project name, language choice. JavaScript is obviously a very popular and well-supported option. Then C3 just scaffolds out the basic project structure for you.
So we've got the basic files. What's next for actually configuring this worker?
The core configuration is in a file called wrangler.toml. This holds key settings, like the worker's unique name, the main entry point file for your code, and really importantly, the compatibility date.
Compatibility date. Why is that so crucial? Sounds like something you need to watch.
Oh, absolutely. Cloudflare's platform is always evolving, right? New features, updates. This date essentially locks your worker to a specific version of their runtime.
So it won't break unexpectedly if they change something.
Exactly. It's like saying, run my code using the runtime as it was on this date. It protects you from potential breaking changes. Although Cloudflare tries hard to avoid those, it gives you control.
Got it. And there are other flags in there too.
Yeah, compatibility flags. They let you opt into specific runtime features. A really useful one is Node.js Compat, which lets you use a lot of familiar Node.js APIs inside your worker.
Okay, so wrangler.tom is our command center. Now the actual code, where does that live? What does it look like?
The file you specify as main, usually index.js or maybe index.ts, typically exports an async function called fetch. This is the main handler for any incoming HTTP request to your worker.
And get some arguments.
Yep, three main ones: request, NV, and cityx.
Okay, request seems obvious enough. That's the incoming HTTP stuff.
Exactly. It holds all the details. Headers, body, the method like GET or POOS. It's based on the standard fetch API you might already know from browsers, just with some Cloudflare additions.
Makes sense. And NV, what's in there?
NV is super important. It's where you access environment variables like API keys you don't want in your code. And crucially, as we'll see later, it's how you access your bindings to other Cloudflare services.
Bindings, like connecting to D1 or KV.
Precisely. Those connections show up automatically on the NV object when your worker runs.
Cool. And the last one, CTX.
XTX stands for execution context. It gives you methods to manage the worker's life cycle, like extending its runtime if it needs more time, or handling specific events, and ultimately your fetch function has to return a response object, again, standard fetch API style, defining what gets sent back to the client.
Now, when we're structuring this serverless code, should we aim for one big function handling everything or break it into smaller pieces?
Yeah, the book mentions this trade-off. You could have one monolithic function handling all routes, or you could break it down maybe one function per API endpoint.
Pros and cons to both, I imagine.
For sure. The book suggests starting simple, maybe with a single function, especially early on. You can always refactor later if it gets too complex. Deploying workers is so fast that refactoring isn't as painful as it might be traditionally.
What about tasks that aren't triggered by an HTTP request, like running something every hour?
This chapter just briefly mentions that scheduled tasks are possible. Cloudflare workers do support cron-like schedules, but the book dives into the specifics of setting those up later on.
Okay, so we've written code, configured it in wrangler.toml. How do we push it live?
It's super simple with Wrangler, just npm run deploy. That bundles everything up your code, the config, and uploads it to Cloudflare's global network. Your worker is live almost instantly.
Wow, that sounds really streamlined. Are there any gotchas limits we should know about?
Yeah, a couple of key ones. There's a code bundle size limit. On the free plan, it's 1 megabyte after compression.
Good.
Goes up to 10 MB on the paid plan. And there's a limit on the number of workers you can have, 100 free, 500 paid. The author notes they haven't hit these personally, but it's good to be aware of, especially if you build lots of small services.
Good to know. Okay, that feels like a solid start, deploying a basic worker. Chapter 2 moves on to building a serverless API. Seems like the next natural step. What's the first hurdle when you go from one function to a proper API?
Well, the big one is routing. Your worker now needs to handle different URLs, right? Like images versus users, and different methods on the same URL, like goodET versus post.
Right, you need to direct traffic inside the worker.
Exactly. You need a way to say, if a GET request comes for images, run this code. If a POST comes for images, run that code, like directing traffic at an intersection.
So how do we manage that complexity?
Yeah.
Does Cloudflare have something built in, or do we use a library?
The book recommends a really neat package called IDI It's tiny, fast, and designed specifically for environments like Cloudflare workers.
UDI router. Yeah.
Yeah, it lets you define routes really cleanly. You map specific paths and HTTP methods to handler functions, the bits of code that actually do the work for that endpoint.
That definitely sounds better than a giant ifills block in the main fetch function. What about testing this API as we build it? We don't want to npm run deploy every 5 seconds.
Oh, definitely not. Cloudflare has great local development support. You run npm run dev, and Wrangler starts a local server that mimics the real Cloudflare environment.
Ah, so you can hit it with requests locally.
Exactly. It gives you a local URL, often on a .workers.dev domain, so you can use your browser or tools like curl to test your API just like it was live, but without actually deploying. It speeds things up massively.
Huge time saver. Okay, routing handled, local testing sorted. What about the actual code for each endpoint, these HTTP handlers?
They're just JavaScript functions. You'd create a function, say getImages, that handles getT requests to images. Inside that function, you write the logic, maybe fetch data, format it. It gets the request object, so it knows about headers, query params, whatever.
And it can access N too for secrets or database bindings.
Yep, exactly. And then it returns a response. So you might have getImages, createImage, getUser by its separate functions for separate jobs.
The chapter then talks about creating stuff using POST requests.
Yeah.
How do we get the data the user sends to the API?
Usually that data comes in the request body, often as JSON. The request object has a handy method, request.json. It just parses the JSON body for you.
It's nice and easy.
Yeah, so your create image handler would call request.json, get the image details, and then, well, in this chapter, maybe just log it or store it temporarily in memory before we get to databases.
APIs often need to fetch specific items, like images 123. How does router handle those dynamic parts of the URL?
It makes that pretty easy, too. You define placeholders in your route path using a colon, like images.ied.
Okay, the colon.id.
Right. When a request like images 123 comes in, router automatically extracts that 123 value and puts it onto the request object, usually in request.params.id.
So the handler function can just grab it from there.
Yep. The book shows a get single image handler doing just that, getting the id from request.params and using it to find the specific image.
So by the end of Chapter 2, we've basically got a functioning, routable API, albeit using in-memory data for now. But we can test it locally. The next really critical piece is automated testing, which is Chapter 3. Why is that so vital here?
Well, automated testing is just crucial for any serious software, right? Especially APIs. As your code changes, as you add features, tests catch regressions, things you broke accidentally.
Saves you from shipping broken code.
Exactly. It gives you confidence that your API actually does what you think it does under different conditions. It's a safety net.
Makes sense. The book recommends vtest for testing workers. Why vtest?
It's presented as being really fast and modern, integrating well with the kind of tools you're often using with Cloudflare, like TypeScript. Easy setup, good performance, those are the main points.
So how do we structure these tests? What does a typical test file look like?
You'd usually have a dedicated test file, maybe in sarc test index.test.ts. Inside, you use vtest functions like describe to group tests for, say, the images endpoint.
Okay, grouping them.
And it to define individual test cases, like it should return a 404 for unknown routes, or it should return images for a JIT request. Inside it, you write code to simulate sending a request to your worker, and then use vtest expect function to make assertions about the response.
Assertions like checking the status code or the response body.
Exactly. The book shows examples like testing for a 404 status, testing a JIT to images checks for a 200 status, and that the body is valid JSON in the right format. Or testing a PST to images checks for a 201 created status and maybe confirms the return data looks correct.
So quite detailed checks. And running them is just another command.
Yep, usually npm run test. That kicks off Fitest, it finds and runs all your tests, and then spits out a report showing what passed and what failed.
Okay, tests give us confidence. But that in-memory data from Chapter 2 isn't realistic. Chapter 4 introduces D1 for persistence. What's the lowdown on D1?
D1 is Cloudflare's serverless SQL database. It's built on SOQL, which is super interesting because, as the book notes, Squillet was kind of serverless before serverless was cool, simple, file-based.
Yeah, true. So D1 brings SQL to the serverless world.
Pretty much. You get tables, indexes, transactions, backups, the familiar relational database stuff, but fully managed by Cloudflare. No servers for you to provision or maintain.
That sounds really appealing. How does it compare to other options, like just using KV or R2?
Well, D1 is for structured relational data where you need SQL query power. KV is more for simple key-value caching, super fast reads. R2 is for large, unstructured blobs like files. D1 fits that traditional database role, integrated right into the worker environment.
Okay, different tools for different jobs. How do we create a D1 database and hook it up to our worker?
You use Wrangler again. npx wrangler D1, create your database name. That sets up the database. Then, crucially, you need to bind it in wrangler.toml.
Another binding like for services.
Exactly. You add a D1 databases section, give it a binding name, how you'll refer to it in code, maybe just DB, and provide the database ID that Wrangler gave you when you created it.
Got it. Now, databases need schemas, tables, columns. How do we define those in D1?
D1 uses migrations for schema management. You generate a migration file with Wrangler. npx wrangler D1 migrations, create your database name, create image stable, for example.
And that creates a SQL file.
Yep. You write standard SQL create table, alter table, create index statements in that file. Then you apply the migration using Wrangler D1 migrations apply, specifying local for testing or remote for production. Wrangler keeps track of which migrations have run.
Nice. Schema managed. Now, the code part. How do we query this D1 database from our worker?
Inside your worker code, that binding name you chose, DB maybe, appears on the end object. So you'd use nv.db. Cloudflare provides an API on that object.
What does that API look like?
You typically use nv.db prepare, To create a prepared SQL statement, you pass your SQL query string to that.
Prepare statement style for security. Prevent SQL injection.
Exactly. Then you can use .bind to safely add parameters to the query.
Yeah.
And finally, you execute it with methods like .all to get all results first, to get just one row, or .run for statements like insert or update that don't return rows.
Okay, prepare, bind, execute.
Yeah. The book then shows how to update those API handlers from Chapter 2, the get images, getDimages.iad post images, to use nv.db to interact with the actual D1 database instead of the old in-memory store.
So now we have a proper API with persistent SQL storage. That's a big step. Chapter 5 then talks about workers talking to other workers. Why would we need that?
Well, as apps get bigger, you might want to break them down. Microservices style, almost. Maybe one worker handles just authentication, another handles the main API logic.
Separation of concerns.
Exactly. Worker-to-worker communication lets these specialized workers collaborate internally, making the whole system potentially more modular and easier to manage.
How does Cloudflare facilitate that internal chat?
They have a feature called service bindings. It creates a direct link between workers in your account. The cool part, as the book highlights, is that this communication happens internally on Cloudflare's network.
So it's fast and maybe cheaper.
Yeah, faster than going out to the public internet and back. And critically, these internal calls don't count towards your request limits or billing. It's free and efficient.
Free internal calls. Nice. How do we set up a service bind? Is it in wrangler.toml again?
You guessed it. In the wrangler.toml of the worker making the call, you add a services array. Inside that, you define an object with a binding name, how you'll call it in code, and the service name, the actual name of the worker you want to talk to.
Okay, so bind the auth worker to the API worker, for instance.
Exactly. The book uses that example. Creating an auth worker, then binding it inside the photo API worker so the API can call the auth worker to check permissions on incoming requests.
I'm making the call in the code. How does that look?
Once the binding is set up, Cloudflare injects an object for that service onto the env object, just like D1 or KV. You use the familiar fetch API on it, so nv.aufee.fetch, a validate token or something similar.
So it looks like a normal fetch, but it's actually an optimized internal call.
Precisely. Same syntax, but much more efficient under the hood. The book shows the photo API worker using this to check credentials with the auth worker before processing any image requests.
Service bindings seem really powerful for building more complex distributed systems on workers.
Okay, switching gears slightly. Chapter 6 introduces Cloudflare Pages for static sites. What's the deal with Pages?
Pages is Cloudflare's platform specifically for hosting static websites and also full-stack applications. Think of it as a modern alternative to traditional web hosting or just dumping static files in S3.
How is it better than, say, just using R2 for static files?
Pages is more integrated. It handles the build process, deployment, provides CI/CD features through Git integration, and serves the content from Cloudflare's global edge network for super fast delivery. It's optimized for that front-end developer workflow.
So deployment is different from workers, more Git-focused.
Often, yes. You connect your GitHub or GitLab repo to Cloudflare Pages. Then every time you push to your main branch or other configured branches, Cloudflare automatically builds and deploys your site.
Does it understand frameworks like Next.js or React? Oh, yeah. It has optimized build settings for many popular frameworks. The book shows creating a Next.js project with C3, and deploying it to Pages often just involves connecting the repo and maybe running a standard npm run deploy script that Cloudflare helps set up.
Pages also has this idea of preview versus production environments.
Right. When you connect your repo, you designate a production branch, like main or master. That's your live site. Any other branch you push automatically gets built and deployed to a unique preview URL.
So you can test feature branches live before merging.
Exactly. It's great for review and QA before changes hit production. You manage the production branch setting in the Cloudflare dashboard.
Can Pages do more than just static files? Can we run backend code? The book mentions serverless Next.js routes.
Absolutely. That's a key feature. While Pages is great for static assets, you can also deploy serverless functions alongside your front-end code. These are often called Pages functions.
So like workers, but integrated with the Pages deployment.
Kind of. For Next.js apps on Pages, you put these functions in the standard Circapa directory. They run on Cloudflare's edge, close to users, giving you low latency for dynamic back-end tasks. They get request context and access to M bindings, similar to workers, though the wrangler.tom fill setup might be slightly different.
Chapter 7 then digs into actually using that backend capability. How do we create those serverless API routes within a Next.js Pages app?
In your Next.js project for pages, you just create files inside Circapi. If you want an endpoint at AppyWeather, you might create circapiweatherroute.ts.
And inside that file,
You export functions named after HTTP methods. So export an async function named get to handle GET requests, post for post requests, and so on. These functions get the request object.
so you can grab query parameters or the request body inside that get or post function.
Exactly. You can use request.nextRel.search params to get query params. The book shows creating an AppyWeather route that takes a location query param, calls an external weather API, and returns the data.
And how does the front-end code running in the browser call this AppyWeather route?
Just like any other API call, you use the browser's fetch function or a library like Axios to make a request to appyweather.location London, for example. Then you process the JSON response in your front-end JavaScript to update the UI.
Pretty standard API interaction then.
Yeah. The book shows updating the front-end weather app component to call this new route and display the results. It also mentions setting runtime edge in your route file to ensure it runs on Cloudflare's edge for best performance.
Okay, dynamic data handled.
Yeah.
But what about performance? Chapter 8 brings in Cloudflare KV for caching. What is KV?
KV stands for key value. It's Cloudflare's globally distributed low-latency key value store. It's designed primarily for fast reads.
How does it achieve low latency globally?
Data is stored centrally but intelligently cached at Cloudflare's many edge locations worldwide. When data is requested, it's served from the nearest edge cache, making reads incredibly fast, especially for frequently accessed data.
So it's perfect for caching things like API responses or frequently needed configuration.
Exactly that kind of use case. It integrates really easily with workers and pages functions.
How do we set up and use a KV namespace?
Again, wrangler. npx wrangler, kv.namespace, create your namespace name, then you bind it in wrangler.toml, just like D1 or services. For KV, it's common to have separate bindings for preview and production environments.
Different caches for testing and live?
Makes sense, right? So you'd have nv.preview.kv namespaces and nv.production.kv namespaces sections, each with a binding name and the namespace id.
The book mentions eventual consistency for KV. What does that mean practically?
It means that when you write data to KV, it might take a short time, typically up to 60 seconds, for that change to be reflected across all edge locations globally.
Ah, so a read shortly after a write might get the old value.
Potentially, yes, from a different edge location. Writes go to central stores first, then propagate out. For many caching scenarios, like catching that weather API result for 10 minutes, this slight delay is perfectly fine. But it's crucial to understand if you need absolute immediate consistency for reads after writes.
Good point. So how do we use it in code? Put, get, delete.
Yep. Once bound, the namespace appears on context.env in pages or env in workers. You use methods like .getKey to read, .putKey value to write. Values are usually strings, maybe JSON streamified, and .deleteKey to remove items. There's also .list to get keys.
And the weather app example uses this.
Yeah, the book shows updating the AppyWeather route. First, it checks KV using .get. If the weather data for that location is cached, it returns it immediately. If not, it fetches from the external API, then uses .put to store the result in KV with an expiration time before returning it.
Smart caching logic. Okay, Chapter 9 moves to file storage with R2. What's R2?
R2 is Cloudflare's object storage service. Think Amazon S3, but from Cloudflare. It's designed for storing large amounts of unstructured data, images, videos, logs, backups, anything really.
And a key feature is S3 compatibility.
That's a big selling point. If you have apps using S3, migrating to R2 can be relatively straightforward because the API is largely compatible.
How does it compare on pricing or integration?
The book mentions R2 has a generous free tier and competitive pricing based on storage used and operations performed, reads writes. A major advantage is its tight integration with the rest of the Cloudflare platform workers, pages, etc., and potentially zero egress fees depending on how you access it.
Zero egress.
Yeah.
That's often a big cost with other clouds. How do we create a bucket and upload files from, say, a pages function?
Create a bucket with Wrangler. npx wrangler R2 bucket, create your bucket name. Then, you guessed it, bind it in wrangler.tomshul under an R2 bucket section, giving it a binding name and the bucket name.
And in the code.
The binding appears on context.env or env. You use methods on that binding object like .put.objectKey data to upload data, often an array buffer or readable stream from a file upload, and .getObjectKey to retrieve objects.
So you could build an image upload feature.
Exactly. The book shows building a Next.js app with a file input form. The form submits to a serverless route, which reads the file data from the request, uses context.env.war2bnv.put to upload it to the R2 bucket, and maybe returns the URL of the uploaded image.
Okay, image upload sorted. Chapter 10 gets really futuristic. Workers AI. What can we do with this?
Workers AI lets you run various AI inference models directly inside your Workers or Pages functions right on Cloudflare's Edge network.
AI at the edge, like what kind of models?
Things like text generation, translation, embeddings, and, relevant to the R2 example, image classification. It brings AI capabilities much closer to the user, reducing latency and simplifying deployment. It went GA in 2024, so it's a pretty current feature.
How do we actually use these AI models from our code?
You need an AI binding in wrangler.toml. Add an A section and give it a binding name, e.g. AI. This doesn't point to a specific resource you create, but rather gives you access to Cloudflare's catalog of models.
So the binding gives access to the AI service itself.
Right. Then in your code, you use context.env.ai.run. You pass it the specific model ID you want to use, like at CHEF Microsoft ResNet 50 for image classification, and the input data, like the image data as an array buffer.
And it returns the model's output.
Yep. The book shows enhancing the image upload route. After uploading the image to R2, it takes the image data, sends it to Workers AI using env.ai run with an image classification model, gets back the classification results like cat, dog, landscape, and sends those results back to the front end to be displayed.
That's seriously cool.
No.
Are there costs or limits with Workers AI?
There are. The book mentions free daily limits on certain models or numbers of inferences when it was written. These details change, so you definitely want to check the official Cloudflare Workers AI docs for current pricing and quotas.
Always check the docs. Okay, chapters 11 and 12 introduce asynchronous workflows with Cloudflare queues. Why go async? What's the benefit?
Async processing is great for tasks that don't need to happen immediately while the user is waiting. Think sending emails, processing uploaded images, generating reports.
Things that can happen in the background.
Exactly. Offloading these tasks to a queue makes your main API faster and more responsive. It also improves resilience. The queue acts as a buffer if your processing service is busy or temporarily down. The task just waits in the queue.
Makes sense. So Cloudflare queues enables this. How does it work? Producing and consuming messages.
First off, queues is a paid feature, part of the Workers paid plan. You create a queue with Wrangler. NPX Wrangler queues create your queue name. Then you bind it in wrangler.toml.
Okay, create and bind. How do we send a message?
From the worker that wants to trigger the background task, like our image upload handler, you use nv.yourQueueBinding.send message data. The message data is typically a JSON object containing info the background task needs.
So send the image ID to the queue after upload.
Perfect example. The book shows the upload route sending the image UUID to the queue. Then you need a separate worker configured as a consumer for that queue.
A dedicated worker to process queue messages.
Right. You configure this in its wrangler.toml using a queues.consumer section, linking it to the queue name. This consumer worker will have a special queue event handler function.
What does that queue handler do?
Cloudflare invokes this function automatically with a batch of messages from the queue. The function gets an array of message objects. You process each message, for example, get the image ID, fetch from R2, analyze with AI, update D1. Crucially, you must call message.ack for successfully processed messages to remove them from the queue.
And if processing fails?
You can call message.retry to put it back in the queue for another attempt later. There are settings for max retries and dead letter queues too.
Sounds robust. The book also mentions R2 event notifications connecting to queues.
Yeah, that's another way to trigger queue messages. You can configure your R2 bucket to automatically send a message to a specified queue whenever an event happens, like a new object image being created.
So the upload itself triggers the queue message, skipping the need for the upload handler to explicitly send it.
Exactly. It makes it more event-driven. Upload finishes RR2, sends message DAC, consumer worker picks it up.
Very neat. Chapter 13 moves into real-time territory. WebSockets and durable objects. What's the story here?
WebSockets provide that persistent two-way communication channel between a client, browser, and server, unlike the standard request-response cycle of HTTP, perfect for chat, live updates, collaboration.
And durable objects are Cloudflare's way to manage the server-side state for these connections.
Precisely. Durable objects, or DOs, are stateful serverless objects. Think of them like individual actors that can hold data in memory and storage and manage WebSocket connections. Each DO instance has a unique ID and guarantees that only one instance of that ID is active globally at any time.
So one DO could represent a chat room holding its messages and connected users.
That's a classic use case. You define a durable object class. Its fetch method handles incoming requests. To handle WebSockets, it detects an upgrade request, creates a WebSocket pair, one end for the client, one for the server DO, returns the client end in the HTTP response, and then uses the server end internally to handle messages.
How does the DO handle incoming WebSocket messages?
The DO class has event handlers like WebSocket message, Remulorn message, which fires when a client sends a message, and WebSocket close when a client disconnects. Inside WebSocket message, you might broadcast the message to other clients connected to the same DO.
And it can persist data, like chat history.
Yep. DOs have built-in storage accessible via this.ctx.storage. You can use methods like .put, .get, .delete on this storage to save state related to that specific DO instance, like the chat room's history. The book walks through building a simple chat app using a DO to manage connections and broadcast messages.
Durable objects sound incredibly powerful for stateful, real-time apps. Okay, wrapping up, chapters 14 and 15 cover automation and production deployment. How does Cloudflare help automate deployments?
Several ways. Manual via Wrangler, sure, but also built-in Git integration for both workers and pages. Connect your GitHub GitLab repo, push to a branch, and Cloudflare deploys automatically.
Simple cases covered. What about more complex pipelines?
For that, you'd typically use a CI/CD platform like GitHub Actions. The book shows setting up a GitHub Actions workflow, .githubworkflowsdeploy.eml.
What would that workflow do?
It could trigger on merges to main. Steps might include building a Next.js front end, using Next on Pages maybe, deploying it using the Cloudflare Pages action, building and deploying a separate backend worker using Cloudflare Wrangler action, and even running D1 migrations automatically. You'd use secrets for API tokens.
Fully automated build, test, deploy pipeline. And finally, pushing to production. Key considerations.
Using your own custom domain, obviously, which you can register or transfer to Cloudflare. Managing environments properly dev, preview, production, potentially using separate Cloudflare accounts for isolation.
What about routing and scaling?
You might use DNS to route different paths or subdomains to different workers. Canary deployments using traffic splits are great. Gradually roll out a new version to a small percentage of users first.
Performance, monitoring, security.
Leverage Cloudflare speed settings for performance tweaks. Use Cloudflare logs for monitoring and observability. And definitely look into Cloudflare Access for securing your apps, maybe integrating with identity providers, all crucial for production readiness.
Wow. This has been an incredibly thorough journey through Cloudflare's serverless world. We've gone from that first npm create Cloudflare to deploying complex, stateful, AI-powered, database-backed applications with automated pipelines.
Absolutely. The platform really covers a huge amount of ground. Workers, pages, D1, KV, R2, AI, queues, durable objects. It's a very comprehensive toolkit. You can build so many different kinds of applications without ever thinking about managing a traditional server.
From simple APIs to these really advanced solutions.
Yeah, the potential is vast. Fast static sites, robust APIs, real-time collaboration tools, background job processing, AI features. It's all there.
So for you listening, what's the main thing to take away from this deep dive?
I think it's the sheer capability and integration Cloudflare offers developers. The book really showcases how these different services work together. Definitely explore it yourself. The free tiers are generous. The documentation is excellent. Start experimenting.
And maybe the final thought to leave you with is this. Serverless tech keeps evolving. Cloudflare keeps innovating. Given these powerful globally distributed tools, what amazing things could you build next? Thanks for joining us on this deep dive.